Okay, so we are going to finish up with the bonding basics worksheet today. You were supposed to have already filled in the table, the top part, so we're going to start right below that. At the end of the video, I will put a completed table up for you so you can check your work. Right now, we're going to answer some of these questions. I'm going to do some sample problems to kind of show you what you need to do for the rest of the bonding basics worksheet, which will be due tomorrow. So to begin, an atom that gains one or more electrons is going to have what kind of a charge? Well, it's an electron. Electrons have a negative charge. So this atom is going to have a negative charge to it. An atom that loses one or more electrons is going to have a positive charge. An atom that gains or loses one or more electrons is referred to as being an ion. Okay, an ion is going to be a charged atom. It's no longer really even an atom anymore. So a positive ion we call a cation. This in a way says it's because cats are positive. And a negative ion is called an anion. Just to kind of go over how we're going to do these next few problems is we're going to look at the periodic table, and I showed you the math, the way you needed to figure out how many valence electrons there are, because valence electrons are the ones that deal with the actual forming of bonds, whether it's ionic bonds or covalent bonds. So our very first column over here on our table, talking about this one right here. Okay, that column, every column in that, okay, has one valence electron. Every single one of them. Okay, so this is one valence. I'm in trouble with the pen here. There we go. One valence electron. Okay, the next column over to the right has two valence electrons. These guys have 3, 4, 5, 6, and 7. And then we've got our noble gases in the yellow. Okay, right there. These are noble gases. They all have a full amount, okay? Whether it's 8 or 18, whatever it happens, or 2, okay, in the case of helium, they're the ones that are already happy. So, if we have one valence electron, we go back to hydrogen or lithium or sodium, what are they going to do? Is it easier to give up 1 or gain 7? Okay, so the smaller numbers are going to give up 1. Okay, so hydrogen would give away an electron. Beryllium, magnesium, calcium, they're going to give away 2 electrons. Boron, aluminum, okay, they're going to give away 3. Carbon can either give 4 or accept 4. And you're going to see that more with covalent bonds now, once we kind of get over to this right-hand side. Nitrogen is going to gain 3, oxygen is going to gain 2, fluorine is going to gain 1, okay? Because remember, in order to be happy, they want to have that full valence level, okay? So these numbers at the top of the periodic table just are to tell you how many valence electrons there are, okay? So if we go on to show kind of how ionic bonds work, okay, atoms will transfer one or more electrons, in this case, to another to form that bond. Each atom is left with a full, okay, outer shell, and an ionic bond is going to form between a positive, so a positive charge, that kind of ion would be a cation, and an anion would be the one with the negative charge. So to show this, we've got sodium and chlorine, okay? So sodium, if we go back to our periodic table, is located right there, okay? So it's going to have one valence electron. Okay, just one hanging out right here. Okay, that's what the dot represents. Chlorine. Oops. I don't know why I did that, but let's see. eraser. 10. Okay, there we go. Chlorine, okay, has 7. I know that, show you. Okay, so located right there. So then we go back, okay, and what you do is, for these, you're going to show sodium giving up that electron, okay? So that's our first step. This is step 1. Our second step shows a positive sodium and a negative chlorine, okay? Those together would equal NaCl. Then we're going to come over here and do this next one. We've got magnesium and we've got iodine. Okay, we go back to our periodic table. Magnesium has 2. Okay, and iodine, find it over here, has 7. Okay, whoops, wrong way, there we go. So magnesium has 2 electrons. Iodine has 7. Okay, so iodine only needs 1 more. So magnesium is going to give its electron to iodine, but magnesium is still left with 1, and so it's not happy. So we're actually going to install a whole nother iodine so that magnesium can be happy too. It's going to give its electron there, and we are left with Mgi2. That's where those subscripts come from. Okay, so that's how you do ionic bonds. All right, next up are covalent bonds, and covalent bonds are a little bit different than ionic bonds. So ionic bonds dealt with the giving up of an electron. In this case, atoms are going to be sharing. Oops, pen. They're going to be sharing electrons. Okay, and they can share 1, they can share 2, they can share 4 electrons. It just depends. So each atom is left with a complete or full outer shell. And a covalent bond is going to form between 2 atoms. Okay? So, if we look at this, we've got hydrogen and hydrogen. Okay? Hydrogen has 1 electron in its outermost shell. Okay? As does this guy. Okay, so what they're going to do is they're going to share those electrons. And we represent this by drawing a circle around it. Okay, he's got 2, he's happy. He's got 2, he's happy. So that circle just shows that, and we are left with hydrogen gas. Okay, next up we've got 2 hydrogens and 1 oxygen. So we've got our 2 hydrogens, okay, each with 1 electron. Oxygen has 6 electrons. If you're not sure on how many electrons there are, go back to your periodic table, check. Okay, so in order for these guys to be happy, hydrogen each needs 1 more. There we go. Okay, and oxygen needs 2 more electrons. So this makes a pretty nice and neat package. Okay, so for hydrogen, right there. Okay, it's going to attach itself to one of the oxygens. And then our oxygen, just going to grab a different color so you can kind of see that. Takes its 6 plus both of these and says, all right, we're good. And that's how water is formed. Okay, so a little bit different between how you do these. With the ionic bonds, you show the actual giving up of the electron. And with the covalent bonds, You use a circle around it to represent. It might not be a bad idea to use different colors on this. It might make it a little bit easier for you, but that's your choice. Okay. Then here's the table. All right, I believe we already did the chlorine, potassium, and magnesium before. This is just to kind of show you. Gives you your atomic symbol of them, total number of electrons, number of valence electrons. You didn't have to do this last column. Okay, so chlorine, because it's got 7 valence electrons, needs to gain 1 to fill its outer shell. Potassium, because it has only 1 electron, is going to lose 1 just to get rid of it, then its valence level is full. Magnesium is going to lose 2. Fluorine is going to gain 1. Aluminum is going to lose 3. Sodium is going to lose 1. Nitrogen is going to gain 3. Oxygen is going to gain 2. Hydrogen can either gain or lose 1. It doesn't really matter in this case. Carbon is either going to gain or lose 4 because it has 4. And iodine with 7 is going to gain 1. Okay. And that concludes the bonding basics worksheet. So what I would like you to do is work on the finishing up with the ionic bonds, showing how those work, show all your work for that, and the covalent bonds. If you want to work with a partner, you may do so.